Okay, so we're going to have a look at how you solve slightly more complex linear simultaneous equations. So we're going to start with having a look at question 1. What I want you to do is see how far you can get with this one, and then when you're ready for me to go through it with you, hit play again. So pause for now and then hit play when you're ready. Okay, so if we have a look at this one, we've got two equations that we're trying to solve simultaneously, which means we're trying to work out a value of x and a value of y that would work in both of the equations. So we need to start as normal with our usual way of processing and labeling it. So this is equation 1 and this is equation 2. Okay, and therefore we need to have a look and see, have we got the same number of x's? No. Have we got the same number of y's? No. So we're going to have to manipulate something to make it into the same. So it's your choice. I'm going to say it's much easier at this point to manipulate and change equation 1 and make the x's the same. So what I'm going to do to equation 1, I need to have 4x, so I'm going to multiply everything through by 2. So in this case, remember, it's each part of the equation needs to be multiplied by 2, so I end up with 2 times 2x gives me 4x, 2 times the 3y will give me 6y, and 2 times the 29 will give me 58. Okay, I'm going to pop the other equation back in as well. So that was the 4x plus 2y equals 30. So it's still got my equation 1 and equation 2. Right, these are the two that I have the same. Both of them are positive, so therefore the signs are the same. Okay, and because our signs are the same, we're going to subtract. So I'm going to, remember we do this like column method. So 4x take 4x. That gives me 0x, so I've eliminated my x's, which is what I was aiming to do. I've then got 6y take 2y, so that's going to give me 4y. And then 58 take away 30 will give me 28. Then I need to solve to find y, so I'm going to divide both sides by 4, and that will give me y equals 7. And remember, I'm not finished at this point. I need to now find the other value for x, so I'm going to substitute my y equals 7 into one of the two original equations, whichever one you prefer. I'd say at this point they're both very similar, so it really doesn't matter. So I'm just going to pick equation 1. So that was 2x plus 3y equals 29. And I know now that my y is worth 7, so 3 times 7 will give me 21. So I've got 2x plus 21 equals 29. And then I'm trying to solve to work out what x is. So I would subtract 21 from both sides. That's going to give me 2x equals 8. And then I'm going to divide both sides by 2. And that will give me x equals 4. So my solutions at this point, okay, are x is equal to 4 when y is equal to 7. Remember, you can check it in the other equation that we didn't use, so that was equation 2. 4 times 4 is 16, added to 2 times the 7, so that's 14. 16 add 14, it does in fact make 30. So again, we can self-check and make sure that we have it correct. I'm then going to have a look at a slightly harder question now on question 2, so you haven't necessarily seen this type before. And therefore, I would like you to think about how you would start this one. I'm just going to draw a line down here because there are two different ways of answering this particular question. So as normal, I would say you need to start off by labeling our equations 1 and 2. And then think about whether we have the same number of x's and the same number of y's. If you want to give it a try at this point, then please hit pause and then hit play when you're ready for me to go through it. And we'll have a think. So I've got 5x and 2x. Can't double one or times anything easily at this point to make it into the other. And I don't want to have decimals. So it's not like I could say I do times this by 2.5 because it's going to give me some horrible numbers to deal with throughout. So I don't want to do that. And I also can't do anything with the 4 and the 6 to make one of them the same. So the only way to deal with the slightly more complicated simultaneous equations like this is to do something to both of the different equations. And this is why there are two ways of doing it. You could do it once with the x's, or you could do it with the y's. So I'm going to show you the two different options, and as I say, both will give you the same answer, so when you come to answering the questions, you can do it whichever way you want to. So if I try and get the x's the same, then to get the same number of x's here and here, I need to actually use the lowest common multiple of 5 and 2, which is 10. So I'm going to need to get equation 1 to have 10x, which means I need to multiply through everything by 2. So I'll get 10x minus 8y equals 46. And if I take equation 2 and I multiply that one by 5 this time, because I'm still trying to get 10x, so that's 10x plus 30y equals negative 125. So they're now my two equations, but I have my 10x's the same here. Okay, and because they're the same, they're both positive, so I'm going to be subtracting at this point. So I've then got 10x, take away 10x, that's eliminated that one. And then be very careful, I've got minus 8y minus positive 30y. So remember the minus and the plus there means it's a subtract question. So minus 8y minus 30y gives me minus 38y. So you can use your calculators just to double check that you're doing that correctly. And then again, be very careful, we've got 46 minus 125. So remember when we've got a subtract and a negative next to one another, that's going to become an add. So it's actually 46 added to 125, which gives me 171. Then to solve to get y, I need to divide by negative 38. So just be careful with that one. So divide by negative 38 on both sides, and you will end up with y equals negative 4.5. So make sure you've got the negative there. So negative 4.5 or negative 9 over 2, either is fine. You would then substitute our y value, so negative 4.5, into one of the two equations. Totally up to you which one we want to use. I'm just going to pick equation 1, but it really doesn't have a lot of difference on this one because they both contain negatives at some point. So we have 5x minus 4y equals 23. So you can do it in the sense of 5x minus 4 lots of minus 4.5. Remember, you're multiplying them to give you 23. So when we do our minus 4 times our minus 4.5, that will give me positive 18. So I get 5x plus 18 equals 23, and then solve it to find x. So minus the 18 from both sides, you will get 5x equals 5, and then divide by 5, and you'll get x equals 1. So my solutions then, y equals negative 4.5 and x equals 1. Alternatively, we could have done it the other way with the y's. So I'm just going to change colour so you can see the slight difference here. If I try and get the two y's the same, I'm looking for the lowest common multiple of 4 and 6, which is going to be 12. So equation 1, I need to multiply that by 3. That's going to give me 15x minus 12y equals 69. And then equation 2, I'm going to multiply that one by 2, again because I'm trying to get the 12y. So that's going to give me 4x plus 12y equals minus 50 at that point. Okay, so then we just need to have a look at the things that we have the same. So that's going to be my 12y and my negative 12y, and the signs are different on this one. So because they're different, we're going to add our values together. And remember, we do it column method. So 15x add 4x gives me 19x. Minus 12 add 12y, that's going to cancel out, which is what I wanted. And then my 69 minus 50, okay, or 69 added to negative 50, so it still becomes a takeaway, actually gives me 19. And then you can divide both sides by 19 to get x equals 1, which is good because I had x equals 1 down here. I then do it as normal, so substitute x equals 1 into one of the two equations, and it's totally up to you which one. I think I'll go for equation 2 this time just to be slightly different. So I then have 2x plus 6y equals negative 25. So it's 2 times the 1. That's going to give me 2 added to 6y equals minus 25. And therefore, if I subtract my 2 from both sides, I will end up with 6y equals negative 27, and then divide through by 6, and I will end up with y equals negative 27 over 6, 9 over 2, or negative 4.5. So my actual solutions, by whichever method that I chose to use at that point, is x equals 1 when y equals negative 4.5. So therefore, you've got a range of questions that involve potentially both of these methods.